Okay, hello everyone. I'm Devesh Tati from the Next Genius Foundation. Thank you for joining this session. In today's session, we have Professor Delden and Professor Kuthirummal from College of Charleston, and they are going to help us understand the nitty-gritty about studying engineering at a liberal arts college. So in this session, you'll hear them speak about what is engineering all about. How is the engineering program at a college like College of Charleston or any other liberal arts college? How is it structured? What are the concentrations within the field? We'll talk about what are the kind of students who will do well in this field. Then you'll listen to them speak about the different career options that the students have upon graduation, and finally you'll hear their comments on the future of engineering, right? So a very warm welcome to Dr. Delden, who is the Dean of the School of Science and Math at College of Charleston. Thank you so much, sir, for joining us today.
Thanks, Devesh.
And thank you so much, Dr. Narayanan Kuthirummal, who is the professor and the chair of the engineering department at College of Charleston. We are very excited to meet both of you, and we are looking forward to hearing more about the engineering programs at your college.
Excellent. Well, thank you, Devesh. We really appreciate you having us here today and to get to talk to the students. Thank you, students, for watching this video. So if you want to study engineering or computer science or one of the technical fields in college, it's very important that right now in high school, you do the very best you can in your math courses, right? When you study engineering, you're not a math major per se, you're not a physics major per se, but you are applying mathematical principles, physics principles to solving real world problems that meet some industry need. So here at the College of Charleston, Dr. NK will go into a moment a little bit more about our two engineering programs that we have in systems engineering and electrical engineering with a focus on autonomous electrical vehicles. But no matter where you end up going to study engineering, it's very important that you choose a university that's surrounded by industry and companies where you can get internships, co-ops, and capstone experiences that integrate those companies into your academic experience. And that's one of the things that makes the College of Charleston so unique of a place to offer engineering. We are the only place in the world that has companies making wide-bodied planes. Boeing makes the Dreamliners here, and full-bodied cars. Both Volvo and Mercedes make cars here in town. And we have several other companies in town, and we integrate these companies. If you come here, you'd be an international student. I was an international student when I came to the US to go to college, and it can be a little bit more difficult to get a internship or a co-op out for private industry. So that's why one of the things we do here at the College of Charleston is integrate the companies into required coursework that you have to take in your senior year when you're close to graduation. And one of the things we do is that we have the students make a video documenting their experience. So I have a very short video to play for you. That's a student-made video, but it'll show you one project that we did for Mercedes, which would be a typical project that you could be working on here at the College of Charleston for a company should you decide to come here. So let me share my screen to get this going. It's very short. All right, and here we go.
Mercedes-Benz pitched their project to our class at the beginning of the semester, explaining that while they are happy with using Nagios Core as an IT monitoring tool, it does not show them where down devices are located on their factory floor. They would like for us to build an add-on that would allow them to pinpoint the location of devices so that they can quickly find them, fix them, and make sure that the production line for the factory is running as smoothly as possible. To get started on this project, we first had to simulate our own makeshift factory floor. We did this by installing a Nagios Docker image on a Vagrant virtual machine running on our laptop. We then plugged 5 Raspberry Pis into a network switch. This way we could monitor our own live network of devices. The solution we came up with is a dashboard application that is integrated right into Nagios. We used the Google Maps API to display the factory floor based on KML specifications provided to us by Mercedes-Benz. We wrote this application using JavaScript, HTML, CSS, PHP, and Python.
So yeah, so that's a basic one of the videos our students made of a project they did for Mercedes, and that particular project, they installed it on the factory floor of Mercedes, and they're still using it today to help their technicians pinpoint problems that arise on the factory floor. So yeah, the desire to build things, applying math and physics to solve real world problems is an important characteristic, interest that you should have should you want to study something like engineering, computer science, and come to the US to do that. And make sure you choose a university surrounded by industry. So I'll now turn it over to my partner in crime, Dr. NK, who's going to talk a little bit more about the specifics of the engineering curricula.
Thank you, Dr. Van Delden and Devesh. Let me share my screen.
Yes, sir.
Okay. Engineering at the College of Charleston, and we have 2 new engineering programs. Electrical engineering, it's a traditional engineering discipline with some focus on intelligent autonomous vehicle systems. It could be land, water, or air. I mean, you know, that's going to be the future, all connected systems, Internet of Things. So mainly we are focusing on, you know, autonomous driverless cars because a lot of industries around Charleston. And we expect a lot of growth. As you can see the statistics right there, how this is going to grow. That's the trend. And systems engineering is brand new, a relatively new interdisciplinary engineering discipline covering traditional engineering, such as industrial engineering, manufacturing engineering, electrical engineering, software engineering, etc., and management. To give you an idea, if you just think about your cell phone, it has the display, it has the electrical components, it has the mechanical components. There are people involved. You need, you know, specific software to run it. So it's become really complex nowadays, any system if you take. So you need to know someone who can actually do everything, who is an engineer at the same time, who is also a manager. Okay, so that's the whole plan of developing this new systems engineering program. So right now we have these 2 engineering programs at the college, and then don't want to go through those details. Just want to give you an idea about our curriculum design. There are 4 dimensions of engineering. Oftentimes, earlier times, it was mainly mathematics and physics, for example. But nowadays, that's not completely true. It has the basic sciences, of course. You need, you know, the basic sciences. But you also need the social science aspect. It's not, I mean, if you look at engineering, now it is all, everywhere. People actually meet with the different cultures. They learn different things. They should know how to communicate. So it is actually becoming more and more global. So they also learn basic social science skills, okay? Communication skills, teamwork skills, presentation skills, and so forth, and also business. As you can actually see, the Logitech CEO mentioned, the key to good design is a combination of empathy and knowledge of arts and humanities. So that's why learning engineering in a liberal arts institution is very beneficial to a student, okay? So if you look at the other quadrants, the product and service masterpiece, and then the other major thing that the students will be learning is the design component. So they'll be spending one complete year, 2 semesters on a design project that they can do here in the department, or they can actually, can do elsewhere in an industry. That is in addition to the internship and co-op programs that Dr. Van Delden just mentioned, okay? So that makes it really complete. It's not just the sciences and mathematics, but social sciences, practical applications, and then the design component. So that makes our program really strong in every sense. So just the electrical engineering curriculum, if you look at 92 hours in the major, total 132 hours, and they can complete all these courses in 4 years without any problem. Those who actually come here with the transfer credits can take additional courses, or can even think about another major. We have the option here for students to double major. So that's also possible. Okay, maybe engineering or physics or mathematics, computer science. So they'll be learning basic sciences and math. So the students we expect are, they should like math, tech-savvy students, as Dr. Van Delden mentioned. So basic sciences and differential equations, up to differential equations. So Calc 1, Calc 2, Calc 3, and differential equations. 2 sciences required, physics is required, and they can take either chemistry or biology, computer programming, 8 credits, electrical engineering specifically, 37 credits. And then there are also opportunities for students to take electives, okay, their choice. We actually offer a set of elective courses. And in addition, there are internship opportunities, research opportunities, and also co-op opportunities for the students. And that's the electrical engineering curriculum, a brief structure. And the systems engineering curriculum, very similar. As you can see, they learn basic sciences and mathematics, computer programming, systems engineering. In addition, they learn 12 hours of business, including supply chain management, okay? And electrical engineering students may also take these courses, no problem, okay? But that's not included in their curricula, but here it is included, it is required, okay? And similar to electrical engineering, they can take electives and also, internship and tutorials and so forth, okay? So that basically gives you an idea about the structure of our engineering program offered at the college. Anything else, Sebastian, would we like to add?
No, I think you covered it, unless Devesh has any follow-up questions for us.
Yes, I do. First of all, thank you so much for sharing the structure of the electrical engineering and the systems engineering programs. I do have a couple of questions that I would like to discuss. Number one is, what are certain other concentrations within these 2 engineering? Like, of course, electrical and systems engineering in itself are the concentrations within engineering. But within these electrical engineering, do you see students doing something more specific or taking in some more elective subjects or concentrations?
They can take, I mean, here that's the advantage of being, in a liberal arts institution. And currently we did not develop any concentration specifically for these 2 engineering disciplines, but they can take concentration or, what we call minor for other disciplines in any topic. It could be mathematics, it could be physics, it could be computer science, It could be languages, or anything. It's possible. Okay, but we'll be soon developing more focused concentrations in these two disciplines because this is very new to the college. But they can even think about double majoring. Could be physics, it could be computer science or mathematics, or they can actually take minors in these in any discipline offered at the college, and that's very easy for them.
Yeah, and if I could just add to that, the current structure implements what we call the T model of engineering education, whereas the horizontal bar of the T means broad-based engineering education with all the courses that NK we're talking about a minute ago. And then you dive deep into one area with your elective courses that you take. You have to take 2 elective courses, and then your year-long capstone project. So if you're somebody like me who's more interested in the computer science side of engineering, your capstone project could literally be a software system that you design or some kind of simulation system and so on. But if you're more on the mechanical side, you would like things moving around, physical things, then you could dive a little deeper down that track with your capstone project. So that's the way we kind of tailor make the curriculum a little bit without specific concentrations right now.
Fantastic. That's really helpful. Okay, what do you see the students do post graduation? Like, what are the career options upon graduation for the engineering graduates?
Yeah, so engineering is a great field to study in college because you can get a job right out of school with your 4-year degree. You don't need an advanced degree to hit the ground running with a company. So for the systems engineering majors, they're like the jack of all trades in engineering. They could get a job being a software engineer as part of a software team. Of course, they can get a job on the factory floor with a Volvo or Mercedes here in town, for example, triaging a variety of problems and issues up and down the factory lines. They could be more on the supply chain management side. They could be straight into business. So the systems engineering really provides you that base foundation to do a variety of careers. And then electrical engineering is a little bit more focused, that you would be trained and you would get a job in wiring, networking, and programming up a Internet of Things to solve some engineering problem. And it might be for Mercedes, or it might be for the Medical University of South Carolina, 3 blocks up the road. They have various neuroscience and rehabilitation facilities to help their patients recover from traumatic injuries. It's a system that needs to be wired up, networked up, and programmed up to interact with patients. So any field like that is the type of jobs you would get upon graduation.
Yeah, and several of our students actually also, physics or astrophysics, they also get into graduate school. That option is also open. If they don't want to get into industry right away, they can also go to graduate school. So that option is also there.
Yes, absolutely. Yeah. Perfect. I think that's really great sort of points. That brings me to my next question. That is, what are some of the future trends, or where do you see the systems engineering or the electrical engineering program evolving in the coming years? Or maybe what are some research that is happening in this and which the students should get excited about?
Yeah, it was certainly autonomous electrical vehicles. NK had a slide on this that briefly outlined it. That is definitely a huge industry worldwide over the next 50 years. So we're kind of on the tip of the spear with our EE program, and because it has that focus in the curriculum. And so we built this program around that future trend of a big market in EV, which is very important for our region here because we do have Volvo, Mercedes, Cummins make turbochargers here in town. Bosch makes electrical components. So our curriculum is built towards that future trend of autonomous electrical vehicles.
And also systems, as Dr. van Delden just mentioned, anything if you look at, in modern tech, it's a system. We can look at just one component, as I mentioned, the cell phone. It's a very complex system, so that's evolving. So a lot of opportunities, for systems folks, whether it is medical, or any other industrial unit, it's all systems. So that's what it is in the future. So that's why even that new engineering field came up. it's very new.
Okay. I am now coming towards my final question for you, and that is, there are lots of young, bright high school students who are going to watch this video and learn more about engineering. What is an advice that you would like to share with them? How can they get themselves ready and prepared for a career in engineering? What are some of the things that you think they should be doing right now in their high school?
And NK, you want to go? Yeah.
Yeah. It's engineering. So most importantly, it is mathematics. Okay. So they should have a trend or like towards mathematics. In addition, if they can take physics, and I think that's actually required for schools in India, plus one and plus two. And also computer science is also a part of curriculum. So math is very important. And then if they can also take physics and computer science at high school, that prepares them very well for these two engineering to start with. Okay, at least they can also say that way they'll be able to save some time here. They may be able to directly jump onto their second year because some of these courses are all required. I think in India it's mostly calculus-based physics. That's what they take, and that's what we actually need for these programs. So it's math, physics, and computer programming mainly.
Yeah, I mean, that's the main thing to be prepared to be successful academically when you go to college. And you just need to have that natural curiosity to solve problems. And by paying attention in your math classes and your physics classes, that's going to enable you to solve those engineering problems later on when you go to college. But engineering and computer science today is not what it was 30 years ago when I was going to college. So nowadays, it's a very social process. You're working in teams, your communication skills need to be excellent, your teamwork skills need to be excellent. So you also need to be that person who functions very well in a group setting. Because, I mean, no matter what you do in life, you're going to be working in a group setting. So those skills are also important to be successful as an engineer in life.
Fantastic. Thank you so much, Professor NK and Professor Delden, for sharing all this wonderful information with our students. I really enjoyed having a conversation with you. I am myself an engineer. I studied bioinformatics at the National Institute of Technology here in India. And I myself, actually, I love math. I love solving, solving mathematical problems. And I can totally understand and see that, yes, math is something which is very important. It's the most important part of studying engineering. But at the same time, having curiosity, having aptitude for problem solving, I think that is also something which will help you succeed as an engineer as you move ahead in your career. So I really enjoyed this conversation with you. And of course, the students we will share about your work and your profiles with the students, so they can check out your profile page on the College of Charleston website, and maybe you can expect some of them to drop in a note and maybe ask about your work and about your research. And with that, I would thank you for joining the session today. And it was a pleasure speaking with both of you.
Before you conclude, Devesh, just a second. There are Indian students on our campus, faculty, and there is an Indian community around. So when students come, they won't be like strangers. There are people actually to help them here.
Superb. Thank you so much for sharing that about College of Charleston. And to all the students who are watching this, College of Charleston is a Next Genius partner college. What that means is that you have a chance of winning a scholarship when you go to College of Charleston. So do check out our website, next-genius.com, and learn more about how you can apply for a scholarship at College of Charleston. Thank you for joining.